Bismillahirrahmanirrahim. The topic of discussion is a wave particle nature of matter, or we say that the dual nature of matter. जब हम बात करते हैं dual nature of matter की, it means that it can show particle as well as a wave nature. सबसे पहले हम बात करते हैं Planck's quantum theory की. Actually, in Planck's quantum theory of radiation, it was finalized that the light shows a dual character, which means that it can behave as a material particle as well as a wave. इसी आइडिया को एक्सटेंड किया लुइस डी ब्रॉगली ने इन द ईयर 1924. लुइस डी ब्रॉगली ने प्री एग्जिस्टेड फिनोमिनास को यूज करके एक रिलेशनशिप दिया. रिलेशनशिप किनके दरमियान? इट वॉज अ मैथमेटिकल रिलेशनशिप बिटवीन द वेवलेंथ ऑफ द इलेक्ट्रॉन एंड इट्स मोमेंटम. Yani, he proved that all the particles having motion possess a dual character. It means अगर हम बात करते हैं electrons की, protons की, neutron, atom, molecules, etc., they should possess a dual character. Means they should behave as a material particle and a wave as well. And this is called wave-particle duality of matter. So let's discuss the Lewis de Broglie's concept. As I've already mentioned that Lewis de Broglie used two pre-existing phenomena. As we know from the Planck's equation, and the equation is E is equals to h mu, where this E is the energy, h is the Planck's constant, and mu is the frequency. And the second pre-existing phenomena used by Lewis de Broglie was the Einstein's mass-energy relationship, which is E is equals to mc square, where here m is the mass of the photon and c is the velocity of the photon. Now equating equation 1 and 2. As we can see that the left hand sides of the equation are equal, so the right hand sides will also be equal. That is, mc square will be equals to Planck's constant into frequency, or we can write it as mc will be equal to h mu over c. From the Planck's equation we know that the frequency is inversely related to the wavelength. That is, mu is equals to c over lambda. So, the frequency over c will be equal to 1 over lambda. So, putting the value of frequency over c in this equation, and we get mc will be equal to h over lambda. Now, if this concept is applied to moving electron with a velocity v, तो हम c की जगह v लिख सकते हैं. So, mv will be equal to h over lambda. Or we can rearrange it as lambda is equals to h over mv. This is the Lewis de Broglie's equation for wave-particle duality of matter. In this equation, we have mathematically related wavelength with the momentum of the electron. जिसका मतलब ये है कि at a time a dual nature, as wavelength is for waves and momentum is for particles. हमने यहाँ पे एक ऐसा रिलेशनशिप डेवलप कर लिया जिसमें wavelength and momentum are mathematically related to each other. And this is Lewis de Broglie's equation for wave-particle duality. Now let us consider an electron moving with a velocity of 2.188 into 10 raised to the power 6 meter per second. As we know that the value of Planck's constant is 6.626 into 10 raised to the power minus 34 joule second, and the mass of electron is 9.1 into 10 raised to the power minus 31 kgs. Now let's try to find out the Lewis-de Broglie's wavelength associated with this moving electron. As the formula is lambda is equals to h over mv. Putting the values, that is 6.626 into 10 raised to the power minus 34 joule second, value of the Planck's constant. Mass of electron, yaad rahe, that is in kg, 9.1 into 10 raised to the power minus 31 kilograms, and the velocity 2.188 into 10 raised to the power 6 meter per second. And the answer comes out to be 0.33 into 10 raised to the power minus 9 meter. यहाँ हम इसको नैनोमीटर में भी रिपोर्ट कर सकते हैं. That is 0.33 nanometers. As we know that 10 raised to the power minus 9 is equals to 1 nanometer. So what conclusion can be made from this? Actually, this value of wavelength of electron moving in the first orbit of the hydrogen atom is comparable to the wavelength of the X-ray. और इसका मतलब है कि हम इसको measure कर सकते हैं. It means wavelength को हम measure कर पा रहे हैं for the moving electron. Now the question arises for proton या for alpha particle. As we know that a proton is 1836 times heavier than an electron. तो हम ये कह सकते हैं that if we imagine a proton moving in a straight line with the same velocity as we have mentioned for the proton, its wavelength will be 1836 times smaller than that of the electron. यानी अगर mass बढ़ गया है तो wavelength smaller हो जाएगी. कितनी smaller? It has been observed कि वो बहुत ही कम value देती है in nanometers, for example, इतनी कम that it moves away from the cosmic region as well. लेकिन value है जरूर. It means that it also possess wave nature. सिर्फ फर्क क्या पड़ा? Mass बढ़ने की वजह से. As the mass of the proton is heavier than that of an electron. सिर्फ mass बढ़ने की वजह से उसकी wavelength और ज्यादा छोटी हो गई. कितनी छोटी? 1836 times smaller than that of the electron. And as we know that the alpha particle or the helium nucleus is 7344 times heavier than an electron. तो क्या होगा? So, if the mass is 7344 times greater than that of an electron, then its wavelength will be 7344 times smaller as compared to that of electron. Very difficult to measure that. So, we finally conclude that as the mass increases, then the wavelength associated with that decreases. But they have a wave nature there. Now let's talk about a stone, a moving stone. We consider that a stone of mass 1 gram is moving with a velocity of 10 meter per second. Then the de Broglie's wavelength associated can be calculated by the same formula. Putting the values, we have the Planck's constant as 6.626 into 10 raised to the minus 34 joule second. The mass in kgs is 10 raised to the power minus 3 kilogram. याद रहे कि हमने mass को यहाँ पे किलोग्राम में ही put करना है. And the velocity is 10 meter per second. And the answer comes out to be 6.62 into 10 raised to the power minus 30 meters. Again, a very, very small value. The same conclusion that as the mass has increased, the wavelength associated with has decreased. This wavelength is so small that it cannot be measured by any convincible method. So हम कह देते हैं that the heavy particles have waves associated with them, but they cannot be captured. And we say that the macroscopic bodies don't have the waves. Actually, the phenomena is that every moving object has a dual character, means it possesses the qualities of the wave as well as the quality of the particle. But as the mass has increased, the wavelength associated with that has decreased. So it will have major So it will have the major characteristic of a particle and a very minimum character of a wave.